Howdy guys, so this is example 220, which is a delta to Y conversion circuit. And so I'm going to kind of walk you through this one, how I solved it for this first one, and then how the book solved it after this. So for this one we have a 100 volt source over here, DC. We have a 5 ohm resistor, 36 ohm, 24 ohm, 12 ohm, 6 ohm, 20 ohm, right out of the book. So what we're going to do first off is turn this from a delta to Y circuit. And there's actually two deltas here. There's a delta up here and a delta down here. I picked the bottom one. The book picked the top one. It doesn't really matter. I'm going to solve both of them for you. So here I'm just going to kind of show you this delta. There's the delta that we're going to take. And remember, we're going to change a delta into a Y, right? So this delta is going to go to a Y circuit, okay? And the other interesting thing about the delta to Y is we're going to get the equations to be able to convert them back and forth. For now, I'm just going to write them down. So this is going to be the equations, and this is from the book, but R1, and what is R1? R1, we're going to go up to this. And remember how we have on this side, this is going to be, let's do this in red actually, so it's a little clearer. This is RA, this is RB, and this is RC. So this is RA, RB, RC. And we're going to change that onto the Y's to be R1, R2, and R3. And so the big question I first get, I'm going to put this R1 over here a little bit more, make it a little clearer. The big question I get is, how do you know the order for all of these? How do you know which one's in the correct order? And to me, the easiest way is it's the opposite. So I'm going to draw one more way, and maybe this will help you visualize it a little bit more. I'm going to do a giant delta over here. And we're going to also do a Y inside of it. Okay. So RA, which is on this side, is going to go to R1 because A, B, C, 1, 2, 3, they're opposites. Get that. So RA, which we have over here on this side, RA is going to be the same as R1 up on this side. So it's the opposite side, R1. Same width over here, we're going to have RB on this side, RB, and then that's going to be our R2 on this one. And then on our third side, we've got RC up there, and that's going to be R3 on our Y circuit. So just to reiterate one more time, the opposite of the delta is where the Y is. So, and we go in order, A, B, C, 1, 2, 3. So the opposite of RA1, the opposite of RA is R1 on that side. So RA, R1 is on the opposite. The opposite of RB is R2 on that side. And the opposite of RC is R3 on that side. So that's the first bit to know. So let's transform this circuit then into a Y circuit, because right now we can't solve this. None of our methods that we have so far can solve this. And the problem here is asking, what is I? What is the current going into that? And in order to determine I, we need to know the total resistance, because remember, V total equals I total, R total. And so that's how we have to solve this. So let's go through and solve this one out. I'm going to rearrange the circuit and draw it from a delta to a Y so we can see. And we're going to have a positive, negative, still 100 volt source. This is going to come out. We've still got that 5 ohm resistor. And now we're going to keep the top half, because remember, we're taking the bottom delta. Okay. And so here, remember how we go across? We've taken this whole delta out, and we're replacing it with a Y. So here's our Y. Y, Y, Y. So let me highlight that for you. So remember, this delta has become this, essentially this y coming down here. So for that now, we're going to be able to write in some of the values. So these top ones, nothing changed here. From 5 to 5, nothing changed. From 24 to 24 ohms, nothing changed. From 36 to 36, nothing changed. Now we're going to go for these. So how do we solve for these? We have to write in. So remember, I'm just going to put these one more time in for us to see. This one was RA, this one was RB, and this one was RC. Okay? So now we're going to write this in over here, and we're going to solve these. So RA, the opposite of RA equals what? R1, and that's going to be this resistor right here, R1. Okay, the opposite of RC is 3, so this is going to be R3. The opposite of RB equals R2. So that's how we order them. And again, I'm just following that same opposites rule that I made before. So now, what are R1, R2, and R3? So we started doing R1 here, and R1 is going to be, and this is the way I remember this, so R1, we're looking at the ones, R1 and RA are related, so we're looking for RB and RC, and that's how I remember this. RB, RC over the sum of RA plus RB plus RC. And we can make that a capital B, it doesn't matter in this case. Okay? So R1, remember, is the opposite of RA. RA and R1 are kind of linked. So if you're trying to find R1, you need the opposite too, so RB and RC. Same with R2 equals, you need the opposite. So what's the one? R2 is linked to RB, so we're going to have RA, RC over the sum of RA plus RB plus RC. And then R3 equals, well, that's linked to RC because it's on the opposite side of RC, so we're going to do the multiplication of RA and RB. RA, RB over the sum of RA plus RB plus RC. And we're going to do that. We're going to do that. That just keep our order of operations very clear. Okay? So, how do we solve for this one? We already have RB and RC. So what is RB? Let's go over here to how this is. RB equals 6. 6 times, what is our RC? Our RC is 12. And then we've got over the sum of 20 plus 12 equals 32 plus 6 equals 38. 38. And that's going to equal, we're going to type that into our calculator real fast. And that's going to equal 72 over 38. 2 over 38, or 1.89. Okay? So now we're going to do the second one here, RA, RC. So RA is this one, so that's going to be our 20 times our RC, which is this one, which we picked as 12, over, it's going to be the same underneath there, 38. And we're going to bring that one out to 6.31. And then we've got RA times RB, so RA is 20, RB is 6. So we got 20 times 6 over, same thing, 38, equals 3.16. Cool. Let's see if there's anything else we need on that. No. So these are our values. These are the new transformed values. So 1.89, we're going to pop right in here, 1.89. R2 equals 6.31, 6.31, and then this is 3.16. 3.16, okay? So that gives us the hard part. Now you can see that this we can kind of write out a little easier now. This isn't as difficult of a circuit. We can take our plus and our minus, got cat hair everywhere. And we got a V, we've got this, we've got 5, because remember this one doesn't change to this one, And now we're going to take this and we're going to branch out. I'm going to bring this back in. I'm going to branch this out, bring this back in, and then we've got one more down here. So now I've made the circuit planar, and I've also, because these two are in series and these are in series, I have simplified them. So 36 plus 1.89 equals 37.89. 37.89. And then we've got over here, we've got 24 plus 6.31, so that's what, 30.31? 30.31. And then this one is still 3.16. So now if we take this one, we're going to do R equivalent, because remember these are in parallel now. So 1 over 37.89 plus 1 over 30.31. Take the inverse of that. And if we type that into our calculator, what are we going to get? Let me do this real fast. I didn't solve this one yet. So this is going to be 1 divided by 37. 1 divided by 37.89 plus 1 divided by 30.31. Insert, good, okay. Up minus 1. We got 16.84 equals 16.84. And then this whole bit is in parallel, in series with this. So we're going to do for the next bit, to simplify it out, we're going to add plus 3.16, and that's going to be 0, 9.91, 1990. Okay, and so then when we add in our 5, because remember that's going to get on there, we're going to get what? We're going to get 1990. 90 plus 5, of course, we're going to get 24.9, which is 24.9 R total equals 24.9 ohms. So how did we solve this again? We're just going to go back through. Once we got the delta to y, so we went from delta to y, then the next piece is that we have these two in series and these two in series. And so the sum of those two became this one, this 37.89. The sum of these two became this one, 30.31. And then once these are totaled out, we did the adding these in parallel to create one single resistor, and then we added the parallel plus this first one plus the last one. And that's what we did down here. So this is R total equals 24.9, so V tot equals I tot R tot. Sorry, I'm having trouble writing in that angle. So what can we solve here? 100 equals I total, and then R equals 24.9 ohms. And so we've got what, 100 divided by 24.9 equals 4.01. 4.01 amps equals I tot. So if you look at this one, this is 4.01. The book says we've got 4.40 amps, so we're off by 1/100th. That's fine enough with me, and that's due to essentially a decimal rounding error previously. But essentially that's how we solve these. And so this current, this 4.1 amps, is going to be this I that's coming into this system over there. So it doesn't ask us to break any of the currents down inside of here. It doesn't ask us what the current through R1 is, although we should be able to do that now, because if you look, this is, you have the percentage of it going through this side versus the percentage going through that side. However, it doesn't ask any of that. All it's asking is for I, and that's how we get our I total. So in the next one, I'm going to do it the way the book does, which is essentially the opposite delta. And you can kind of see how it works out.